Hi gang, welcome to another video session. Couple lessons once again. Primary focus today on matrices. Now you've done some work with matrices before, so I think this will be a pretty good review, but we'll maybe do some different things as well. First of all, we say that matrices are equal if and only if they have the same dimensions and are identical. So with matrices, you may remember we have rows and columns. Of course, rows going across like this and columns going vertically. We start out with some problems like this, trying to figure out what y and x might be equal. And the idea is that the corresponding parts have to be equal. So for instance, in this case, we would have to say that y equals 4x. And we would also say that y minus 3 equals 2x plus 1, like that. And we see that this ends up to be kind of a system of equations of sorts. So I think maybe your best strategy on something like this might be to do a little substitution. So if y equals 4x, we could substitute that in place of this y. So we'd have 4x minus 3 equals 2x plus 1. And then rearranging things, we would get that 2x on this side, add 3 to each side equals 4. So of course that means that x would be 2. And if x is 2, we can go back to this earlier equation and see that y would equal 8. So that's kind of the deal on those kind of problems like now. Oh, interrupted by the bell, but don't go anywhere. Now here's another type of matrix problem. Probably more common is to do some addition or subtraction or multiplication with matrices. Here we have two matrices, A and B, each of them 2 by 2, as we can see, 2 rows and 2 columns, so we call them 2 by 2. Can I add these up? Yes, I can, because they have the exact same dimensions. And the idea here when we add matrices is that we just add corresponding parts. So for instance, 3 will be added to negative 3 because they're both in the corresponding part, and so of course there I'll get 0. 6 plus 4 in the upper right there is 10, and then I'm going to get 4 and 3 for my other entries there. Now what about b minus a? Is that going to be the same thing? Well, no. The subtraction is important, so we do have to start with this b matrix, make sure that goes first. We're still doing corresponding entries. So then we'd have to do negative 3 minus 3, which would be negative 6, 4 minus 6, negative 2, 6 minus negative 2, which is 8, and negative 1 minus 4, which is negative 5. Now your calculator can do operations like this, but probably just as easy to do them by hand. Get to some multiplication, and as you might remember, multiplication is just a tad trickier perhaps. I'm just going to write down the dimensions of these matrices to help us out. This is a 1 by 3, 1 row and 3 columns. This one would be a 3 by 1, 3 rows and 1 column. This one of course is a 3 by 3 matrix. So the question is, can you multiply C times D? Now they do not have to be the same size in order to multiply them, you may remember that, but if you remember, what has to be true are the middle numbers when we're multiplying have to be the same. So the columns of the first must equal the rows of the second. And the way we go ahead and multiply these, I'll go ahead and kind of show you. So we take the first entry here times the first entry here. We're just going to end up multiplying single digit numbers here. So 3 times negative 2 is negative 6, and negative 2 times 5 is negative 10, and 4 times 0 is 0. And how big will this final matrix be? Well, just as you can tell, if you can multiply them by looking at the two inner numbers, we can look at the two outer numbers and see what the dimensions of your final matrix will be. So in this case, my final matrix will actually be a 1 by 1. So negative 6 minus 10 is negative 16, and that's it. Now I'm going to move on to another. Can I do D times C? That's just the reverse order. Well, once again, I'm going to write the dimensions and see if this would work. Actually, I'm going to make sure to write them in this order. So D is the 3 by 1 matrix, and C is the 1 by 3. So yeah, once again, because these two middle numbers are the same, I can actually multiply them. And interestingly enough, then my final matrix size will be fairly robust. It'll be a 3 by 3 matrix. I'm going to rewrite these just so it'll be a little bit easier to multiply them. So D is negative 2, 5, and 0, like that. And C is 3, negative 2, and 4, like that. And how do I multiply these? Well, what this is going to end up to be, remember, this is going to be a fairly large matrix. So a good way to help you remember what to multiply is the first position here is row 1, column 1. So that's what I have to multiply here. I have to multiply this row 1 by column 1. So negative 2 times 3 is negative 6. All these are going to be row 1 in different columns. Negative 2 times 2 is 4, and negative 2 times 4 is 8. Then I go down to the next row and multiply again by each of these. That will give me the second row of my answer matrix there. So 5 times 3 is 15, 5 times negative 2, 5 times 4. And lastly, my last row looks like that'll be zeros all the way across. So there we go. That's how to multiply matrices. But remember, if these middle numbers ever do not agree, then you cannot. For instance, if we did C times E here, notice as we've said, C is a 1 by 3, E is a 3 by 3. So can I multiply them together? Yes, I can. And so maybe I'll quickly try to do this. I think I can do it in this order. So every row is going to be multiplied by every column. Notice my final answer will be a 1 by 3 matrix. So it's going to be a long bugger. So notice I'm going to get, it'll be 3 times 2 plus negative 2 times negative 5, 4 times negative 2. So what I'm going to end up with here actually is I'm going to actually try to multiply this out a little bit. Some of these are easier to do in your calculator, but we're going to try to lengthily show how to do them. So if we said 3 times 2 is 6, negative 2 times negative 5 is 10, and 4 times negative 2 is negative 8. Okay, so that's going to give me my one number there basically, which should be 16 minus 8, which is 8. Let's see, how am I going to write this? I think I'm going to go down here. So 8 is going to be my first number. And my next, I'm going to change colors here. That might make things a little bit easier to see. Now I'm going to start with 2, and I'm going to multiply it by all these rows. So 2 times all those columns, excuse me. So negative 2 times 0 is 0. Negative 2 times 6 is negative 12, and negative 2 times 0 is 0. So clearly that's just going to be negative 12. And my last one, again, a row by a column. So this row by this column. So that's going to give me 3 times negative 3. And, whoopsie, excuse me, 4. 4 times negative 3 is negative 12. 4 times negative 1, and 4 times 7 is 28. So negative 16 plus 28 should be positive 12. So that's what I get when I multiply those. Now the last one, 3D, all that really means is I'm multiplying 3 by each of these numbers here. So 3D, what that's going to look like is -6, 15, and 0 like that. So you may recall doing those types of things in advanced algebra. The new thing maybe in this chapter is using matrices to both reflect and rotate various figures. So take a couple minutes and copy this chart down now. We have reflections over the x-axis, the y-axis, and the line y equals x, and rotations of 90 degrees, 180, and 270. Where we use these is we'll kind of show in class where these ones and zeros come up, where we come up with those. We're going to use our calculator and these reflection or rotation matrices to help us do that with some other figures. All right, so let's say we have this particular triangle at -1, 2, which should put it about right here, and 4, 4 up here someplace, and 3, -2. So that particular triangle, which we could call ABC, and we could connect these dots if we wanted to. We want to try to rotate this 90 degrees, and it's always, when we do these rotations, it always is going to be counterclockwise how we look at them. Now we'll see that we can do these actually with matrices. And a key thing to remember is that we can represent ordered pairs in a matrix. And they go like this, kind of vertical in fashion. So there's -1, 2, 4, 4, and 3, -2, like that. That's how I would represent these three ordered pairs forming that triangle in a matrix. In a sense, you can think of as the top row is X and the bottom row is Y, and then we can name each of the points in a column like that. Now we're going to actually show some steps on your graphing calculator how you're going to do this, so you might want to follow along here. To get to matrix, it might be a little bit different in each of your calculators, but basically it's second and the x to the -1 key. They're both on the left-hand column of your calculator. And you get to a menu that looks like this. We want to first of all go over to Edit, and we have two different matrices here that we're going to use. The 2x3 matrix, which is the one we showed on the last slide, and the 2x2 matrix, which is the one that rotates. So you want to go ahead and enter in that matrix just like we showed on that last slide, or you have on your notes. That's matrix A. Then you have to go back to your calculator, hit those keys again, second and x to the -1, and edit to get to the matrix B here. Notice this should match up with what you wrote down on that chart. This is the matrix that rotates things 90 degrees. So you enter both those in there. It doesn't really matter what letter name you give them. So it looks like that. Once you have those locked in there, go back to matrix once again. It's always like you have to kind of start with that main menu, then highlight names, and then you can select whichever ones you want. And what you're going to end up doing all the time here is multiplying B, which happens to be my rotating matrix, and A, which is the matrix representing that triangle. You're just going to multiply those and you get that for an answer. Now, again, the answers you get here are ordered pairs, so we get -2, -1, and -4, 4, which is right about there, and 2, 3, which is right about there. Kind of hard to visualize this, I always think, but if we had both of these graphed in the same grid, you might be able to tell that a little bit better. All right, so that's good for this session. Again, kind of a longer session, but things that you pretty much already know. We'll work on this stuff in class tomorrow. Farewell for today.